Hi there, and welcome to this lesson on Pure Mathematics 4. And in this lesson, we're on Chapter 2, 2.3, and how you solve partial fractions when you have an improper fraction. First of all, what is an improper fraction? Well, numerically, an improper fraction is a fraction where the numerator is greater than the denominator. So, for example, 23 over 5, where 23 is greater than 5. Algebraically, an improper algebraic fraction is an algebraic fraction where the degree of the numerator is greater than or equal to the degree of the denominator. What does that mean? It means, for example, x squared plus 3x minus 5 over 7x plus 1, where the degree of the numerator is 2 because we have a quadratic. The degree of the denominator is 1 because it's just a linear function. Or if you had x cubed plus 4x plus 8 over 2x cubed plus x squared minus 3x minus 6, both of them are cubics, both of them have the same degree, both have degree 3. So both of those would be improper algebraic fractions. Now when we carry out the division 23 divided by 5 or 23 over 5, we could write 23 over 5 is 4 3/5, or we can positively write the and. 23 over 5 is 4 plus 3/5. And it's this second form that we use when we're doing algebraic partial fractions. And just remember, 4 is called the quotient, 3 is called the remainder. Okay, there are two cases. So either the numerator is equal to the denominator in terms of its degree, or the degree is greater than the degree of the denominator. We'll look at case 1 first of all, where they're both the same. So it's where we have a polynomial of degree n divided by another polynomial of degree n. Now, if that's the case, then the quotient is a constant. What does that mean? Well, let's have a look at an example. So let's say we had two linear polynomials. 11x has degree 1, x minus 2 has degree 1, and we had to write that in partial fractions. If the quotient is a constant, what that means is 11x over x minus 2 equals the quotient, and that term a will just be a number, it'll be a constant, plus b over x minus 2, where b is also a constant. Now the method's exactly the same method as we've used in the previous two lessons. So we need to add these two fractions together. It's a little bit more confusing because a doesn't look like a fraction, but if we add those together to get one fraction, we'd get a into x minus 2 plus b over x minus 2. Always check that it makes sense. Now looking at the a term, the x minus 2's would cancel with each other and we'd just be left with a, which is what we want. Looking at the b term, we've got b over x minus 2, which again is what we want. Okay, as I say, same method as in the last two lessons. Using the substitution method, have a go at completing this question. So pause the video, have a go, and then come back to me when you're ready. Okay, let's have a look at this. So that's the question. And using the substitution method, we'd say let x equal 2 so that this bracket on the top will equal 0. And then on the left-hand side, the numerator becomes 11 times 2. On the right-hand side, a into 2 minus 2 plus b. And that gives us b is equal to 22. Now to find a, we have to use the coefficient, equating the coefficients method. And what we want to do in this case is equate the coefficients of the constant term. Now on the left-hand side, on the numerator, there is no constant term. So on the left-hand side, we'll get 0 because there isn't a constant. On the right-hand side, the constant comes from two places, a times minus 2, which gives us minus 2a, and plus b. And then we'll say, well, we know b is 22, which gives us that. And then we can solve that. 2a is 22 and a is 11. Once we know a and b, we can then write this in partial fractions. So 11x over x minus 2 is equal to 11, the quotient, plus 22 divided by x minus 2, where 22 would be the remainder. Now, this particular question is actually a great deal easier to do if instead of using partial fraction method, you just do an algebraic division. So if you're good at algebraic division, it's definitely an awful lot quicker for this type of question, not all of these questions. Algebraic division would just say 11x is equal to x minus 2, and then you've got to work out what you've got to times by. Well, we've got to times by 11, because then 11 times by x will give me the 11x. But I don't just get 11x, I also get minus 22 that I don't want. So I need to add on 22 to cancel that out. But the algebraic division, whilst it's a little bit confusing, it's extremely quick. You just say 11x is x minus 2 times 11 plus 22 and get straight there. Then all we need to do is divide by x minus 2, and that'll give us 11x over x minus 2. Here the x minus 2's will cancel when we divide by x minus 2, and here we get 22 over x minus 2, which is the answer that we had before. Now, if you're good at algebraic division, then that might be a preferable method just for this type of question. Okay, example 2. Write the following in partial fractions. And again, if we look at this, on the top we have a polynomial of degree 2. On the bottom, we also have a polynomial of degree 2. They're both quadratics. Therefore, the quotient is a constant. That means if I write 2x squared plus x minus 5 over x plus 2 plus x plus 1, it'll equal the quotient a plus some constant over x plus 2 plus another constant over x plus 1. Now, I need to add those three fractions together. Obviously, a doesn't look like a fraction. It's a over 1 if you want to write it as a fraction. This time, I'll let you have a go at doing the whole thing. So you need to add all of those three together to get one fraction. And again, I think you use a mixture of the substitution method and equating the coefficients method to find a, b, and c. Anyway, I'll let you have a go at finishing this question off yourself. So pause the video, see if you can work your way through it, and then come back to me when you're ready. Okay, let's have a look at it. So adding those three fractions together to get one fraction, that is what you'll get. And it's always wise just to check that it looks right. So looking at the a term, the x plus 2 and x plus 1 will cancel with the x plus 2 and x plus 1 on the bottom, and I'll just have a, which is what I want. Looking at the b term, the x plus 1's will cancel, leaving me with what I want. Looking at the c term, the x plus 2's will cancel, leaving me with what I want. Then we let x equal minus 1, because both of these brackets will become 0. Substituting minus 1 into the numerator on the left-hand side would give us that. Substituting minus 1 into all of these brackets gives us that. And these two brackets are both equal to 0, which means the a term and the b term just vanish. And we're left with c equals minus 4. If we let x equal minus 2, then these two brackets will equal 0. So putting x equals minus 2 into the numerator on the left-hand side gives me that. Putting it into these terms on the right-hand side, again, two brackets equal 0. The only one that doesn't equal 0 is the term with b in. And that gives me minus b is equal to 1, which means that b is equal to minus 1. Now, we don't have any other brackets we can substitute into, so we have to use the equating coefficients method to find the final constant. It's normally easiest if you use the highest power. It is in this case. So if we look at the coefficients of the x squared terms, in the numerator, we've got 2x squared, so the coefficient is 2. And if we look at this expression here and ask where will we get an x squared term from, well, it only comes from one place. With b and c, I won't get any x squareds, but if I multiply out these brackets and then multiply by a, I will get ax squared. So you don't have to multiply all the brackets completely, as long as you can look at it and see where things are going to come from. The only x squared term is ax squared, so the coefficient will be a on the right-hand side, which means a is 2. So we've now found a, b, and c. A is 2, b is minus 1, c is minus 4. We can write down the answer. So the fraction in partial fractions will be 2 minus 1 over x plus 2 minus 4 over x plus 1. And this question you couldn't really do very easily just by using algebraic division. Okay, example 3. Write the following in partial fractions. Now, if you look at the top, we've got a cubic. If you look at the bottom, if we multiply the brackets, we've got a cubic again. So it is still case 1, this. We've got a polynomial of degree 3 divided by a polynomial of degree 3. So again, that means that the quotient is a constant. What does that mean? It means if we write this in partial fractions, a there is the quotient, and that will be a constant. And then we've got a repeated factor. So you need to remember the work we did in the last lesson. We'll have b over x plus 1, c over x, and also d over x squared. We need both of those terms. We need to add all of those 4 fractions together. But again, I think I'll let you have a go at doing the whole thing. So pause the video, see if you can complete this question yourself, and then come back to me when you're ready. Okay, let's have a look. Adding all of those 4 fractions together would give us that. And again, we'll just go through it to make sure there's no mistakes. Looking at the a term, the x squared times x plus 1 cancels with the x squared times x plus 1, leaving me just with a. Looking at the b term, the x squareds cancel, leaving me with b over x plus 1. Looking at the c term, one of the x's cancels, and the x plus 1 cancels. So I'll be left with c over x. And looking at the d term, the x plus 1's cancel, leaving me with d over x squared, which is what I wanted for each of those 4 terms. Then using the substitution method, first of all, we'll let x equal 0 because of these x squared terms and the x term here. So on the left-hand side, all I'll have is minus 4. And on the right-hand side, these first 3 terms all vanish because x squared and x will equal 0. And all I'm left with is 0 plus 1 times d on the right-hand side, which straight away gives us d equals minus 4. If I then let x equal minus 1, on the left-hand side, I'll get all of this. And on the right-hand side, I'll get a times by 0 because this will be 0 here. The b term will exist, b times minus 1 squared, but both the c and the d term have got an x plus 1 in brackets, so those will also equal 0. That means, simplifying this, I get minus 2 plus 3 plus 1 minus 4 is equal to b, minus 1 squared is 1, and that gives me b equals minus 2. Now, if we look at the coefficient of the x cubed term, so as I said before, it's normally best if you start with the highest power. X cubed is the highest power. On the left-hand side, the coefficient is 2. And if I look on the right-hand side, I don't get any x cubes from the b, c, and d term. The only one I'll get is from this first term. And I'll get ax cubed if I multiply these brackets out. So on the right-hand side, the coefficient of x cubed will be a, and straight away that gives me a equals 2. So that's what we've done so far. We found d, b, and a. We still need to find c. The easiest way to find c is to go down a power and look at the coefficients of the x squared term. On the left-hand side, we've got 3x squared, so the coefficient is 3. Now, on the right-hand side, x squareds come from lots of different places. I'll get ax squared when I do the x squared times by the 1 here, so I will get an a. I've got bx squared, so there's a b. And multiplying out these brackets will also give me a cx squared, so I'll get c. So 3 is a plus b plus c. A and b I know, so that will give me 3 equals 2 minus 2 plus c, which means that c is equal to 3. Therefore, I can write this in partial fractions, putting in the numbers as 2 minus 2 over x plus 1 plus 3 over x minus 4 over x squared. Okay, we've been looking at case 1 so far. Case 2 is where the degree of the numerator is greater than the degree of the denominator. So it's where we have, for instance, a polynomial of degree n divided by a polynomial of degree m, where n is greater than m. The degree of the top is greater than the degree of the bottom. If that's the case, then the quotient isn't a constant, it's a polynomial. And the polynomial will be of degree n minus m. So if n minus m was equal to 2, the quotient would be a quadratic. If n minus m was equal to 3, the quotient would be a cubic. In this example, if you look at the top, we've got a cubic on the top. If I multiplied out the brackets, I'd have a quadratic on the bottom. So the degree of the top is 3 because it's a cubic. The degree of the denominator is 2 because it's a quadratic. We do 3 take away 2. So 3 take away 2 is 1. That means that the quotient is a polynomial of degree 1. Degree 1 is a linear function. It means ax plus b. That would be a linear function. If I got 2, then the quotient would be a quadratic, and so on. Okay, we'll have a look at example 4. So what that means is, if I want to write this in partial fractions, you'll notice the quotient now is not just a constant. It's a polynomial of degree 1. In this case, that's a linear polynomial. And then the rest is the same as before. I get c over x plus 3 and d over x minus 2. And the method is exactly the same as before. So I need to make all of this into one fraction by adding all of these together in the normal way, then using a mixture of the substitution method and the equating coefficients method. This is the last example. I'll let you have a go at finishing the whole thing. So pause the video, see if you can work your way through this, and then come back to me when you're ready. Okay, let's have a look. So if I add all of these together, the easiest thing to do is to keep the ax plus b as one term. And I'll have ax plus b times by x plus 3 times by x minus 2. And those would cancel with the bottom, leaving me with just ax plus b there, which is what I want. Looking at the c term, the x minus 2's cancel, leaving me with what I want. Looking at the d term, the x plus 3's cancel, leaving me with what I want. So I've added the fractions together correctly. First of all, we'll substitute in x equals 2, because that will make these two brackets equal 0. The numerator on the left-hand side equals this when I substitute x equals 2. And on the right-hand side, all of these brackets will equal this. And x minus 2 is 0, and x minus 2 there is 0, meaning the a, b's, and c's all vanish. And I'm just left with 5d is equal to this on the left-hand side. That's where I just got to. That gives me 5d is equal to 5, which means that d is equal to 1. So that's the first constant found. If I let x equal minus 3, then on the left-hand side, the numerator becomes this. On the right-hand side, all of these brackets become this. And again, the term in a and b vanishes. The term in d vanishes. I'm just left with the term in c, which gives me all of this is equal to minus 5c, which means minus 5 is equal to minus 5c, which gives me c is equal to 1. We'll go to the highest power as normal. So if I look at the coefficient of the x cubed term on the left-hand side numerator, I've just got 1x cubed. So 1 here. On the right-hand side, where do the x cubes come from? Well, I don't get any from the d term, I don't get any from the c term. Now I've got 3 brackets being multiplied together here, but you don't need to multiply them out. To get an x cubed term, I'd have to take ax from the first bracket, x from the second bracket, x from the third bracket. That's the only way I can get an x cubed term. And if I multiply those 3 together, I'll get ax cubed. All the other terms will be a lower order, which means the coefficient of x cubed is a on the right-hand side, which immediately gives me a equals 1. If we go down a power and look at the coefficient of the x squared term, it's a little bit harder this. On the left-hand side, it's no problem. The x squared term is plus 4x squared. So I've got 4 on the left. And now I need to ask where the x squareds come from on the right-hand side. Well, none from the d term, none from the c term. They would all come from multiplying these 3 brackets out. Now, if you want to, you can just multiply the 3 brackets out, collect all the terms, and work out how many x squareds there are. It isn't necessary. You could say they come from 3 places, basically. So x from the first bracket, ax, times by x from the second bracket, times by minus 2 from the third bracket. So ax times x times minus 2. That'll give me minus 2x squared, 2ax squared. So doing that will give me minus 2ax squared, so that's part of the coefficient. If I then do the ax from the first bracket times by 3 from the second times by x from the third, that'll give me 3ax squared. So that part of the coefficient will give me 3a. And then lastly, if I take the b from the first bracket, the x from the second, the x from the third, that will give me bx squared. So I'll have plus b here. Now I appreciate that's a little bit tricky. If you're happy with that, then that is the quickest way to do it. If that feels very confusing to you, then you need to multiply these three brackets out, collect all the terms together, look at the coefficient of the x squared term. Now, if I tidy this up here, I got 4. No, before I tidy it up, here I've got 3a minus 2a. So that would be a plus b. If you multiplied all the brackets out and found the coefficient of the x squared term, it'll actually be a plus b that you should get, simplifying this. But what I've done is substitute a equals 1 here. I worked that out from the x cubed term. That gives me 4 equals minus 2 plus 3 plus b. And then I can say, therefore, b must equal 3. Okay, bit of hard work that. But we've now found a is 1, b is 3, c is 1, d is 1. The only thing I need to do now is substitute those in. And that will give me that this in partial fractions is equal to x plus 3 plus 1 over x plus 3 plus 1 over x minus 2. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 13 and have a go at exercise 2C. Thank you very much for listening, and cheerio.